Good morning. We will be talking about physical and chemical changes where we left off before the holidays, and you will find that in your course book, Unit 9, page 108 to 112. Now, what is physical changes? For physical change, no new substance is formed. It is still the same substance. No chemical bond is formed or broken. For example, when we have stacks of books and we squeeze it, it's still the same thing. Also, when we have solid ice, we melt into liquid, and then afterwards it evaporates. We are still talking about the same water. It is a physical change. No new substance is formed. The solid ice will only melt into liquid, which we are still talking about water. While liquid, when we boil, it evaporates. The gas in it is still the same water that we are talking about. So we say in physical change, no new substance is formed. Also, when we add salt to water, if we boil, we will still have to get our salt back. It means that despite the fact that we mix salt and water together, the salt molecules only dissolved in the water. It did not go anywhere. If we want to get back our salt, all we need to do is just to heat the mixture and we will still get back our salt. Saying that no new substance is formed. No bonds are being broken or formed. Now we move to chemical changes. For chemical change, new substance is formed. Also, chemical bond is formed or broken. For chemical changes, there's an irreversible change, because we cannot put whatever substance that we are changing, we cannot bring it back to the original position. For example, if we add iron and sulfur together, when we mix both items together, we cannot change, once we heat, we cannot change it back to the original form. Now, for you to know that a chemical change is in play, there are 5 things you need to take note. For example, if you see burning or fire, then you should know that probably chemical change is about to take place. Now, also, a temperature change without heating or cooling is an indicator of a chemical change. Now, an explosion, if you mix 2 chemicals together and there is an explosion, then know that the chemical change is about to take place. Now, a change in color is also an indicator of a chemical change. A change in odor, when chemicals are being added together and you kind of have a type of smell coming out of it, then it means that a chemical change is about to play. Now, anytime when you mix items and you see bubbles or it fizzes, then there is a chemical change in play. Now, for example, maybe we have mixture of if you want to bake a cake, and we have flour, we have milk, we have egg, we mix everything together. Before putting it in the oven to bake it, we could still separate this substance. We say that is physical change. But once we put this mixture into the oven and we heat, there is no way that we can pull out the... Now, in a short while, after this example, I will be doing a little experiment to show us the difference between a physical change and a chemical change. Now, but before we go there, this is an example of chemical change. When we add iron plus sulfur, it gives a new substance, iron sulfide. Also, it means that iron has reacted with sulfur to form a new substance, iron sulfide. This is the equation. This is iron, this is sulfur. When they are both added, a new compound is formed. So it is no longer iron or sulfur separately. It has become iron sulfide. So which means iron and sulfur, they are the reactants. They are both reacting with each other to form a product which is iron sulfide. So we can see here that the reactant is iron and sulfur, and the product is iron sulfide. Now, in few seconds, we will start an experiment to showcase what physical change is and what chemical change is. You hold on for us shortly. Okay, like we explained about physical and chemical change, we will be doing a short experiment to showcase what physical and chemical change means. Now, like we said earlier on, that if we have a stack of paper and we decided to squeeze some of it, we throw it out, we can still bring it back to its original shape, which means it is reversible. That makes it a physical change. No new substance is formed. We are still talking about paper. No new substance is formed. Also, if we add salt, we have a little bit of water, and we add salt into it. I'm going to mix the salt together for it to dissolve. You can see that the salt molecule is dissolving in the water. Sometimes you might think that because the salt has dissolved in the water, then it's impossible for us to separate this substance. Some might think that it has turned to a new substance. No. For the fact that salt has dissolved totally in water does not mean a new substance is formed. A solution might have occurred, but it is possible for us to get back our salt. So now, after dissolving this salt into this water, I'm going to pour a little bit of it into an evaporating dish, and now, while we wait for our salt solution, we are going to continue. Also, we were talking about ice. If I dissolve, we have ice here. If I dissolve some piece of ice in water, it will dissolve. We are still talking about water. There is no new substance formed. We are still talking about water here. So no new substance is formed. Despite the fact that there is a change, there's a change in state from solid to liquid or from liquid to gas, we are still talking about the same thing, water. No physical change is formed. Now, while we wait for our salt solution to see what happens, now we will move on to a physical change. We will move on to a chemical change. Now we talked about iron and sulfide. In here, I have my sulfur and I have my iron here. Now, if I put my iron here, initially, with this way, all the iron will go to the magnet, right? Now, after which, this is a mixture of iron and sulfide. Iron and sulfur, rather. Now, if I heat this on fire, after some time, this will be the result of what we get. We can no longer separate iron from the sulfur. It has become totally a new substance. So this, we say, is a physical. This, we say, is a chemical change because a new substance has been formed totally. We cannot no longer separate iron from the sulfur. So this is an example of a chemical change that we are talking about. For us to get our salt back, like we said initially, after heating for a while, we'll filter. So this is the result of our physical change, which means we can get our salt back, so no new substance is formed. We will continue talking about chemical change, as we have said that in chemical change a new substance is formed, and for you to know that a chemical change is in play, there are some things that there are some clues that you need to watch out for. Like we said, when burning or fire is involved, then probably a chemical change is about to happen. When you see bubbles or you see fizzles, then chemical change might be occurring. So we will be doing a simple experiment using magnesium metal powder and hydrochloric acid. In here, I have my hydrochloric acid, and I'll be having a little bit of it in my test tube here. Now, what we're about to do is, we are going to see the chemical reaction between magnesium and hydrochloric acid. Now, when we mix the two things together, there's going to be some bubbles to tell us that there's a chemical reaction going on. But we do not know the type of gas that is actually coming out. So for you to know the type of gas coming out, we are going to test it by putting, I have my stick here, and I'm going to put this in fire. We might probably use a splint, but I'm going to use the stick. When I put in fire and I dip in the gas, the pop sound makes you to know that it is an hydrogen gas that is present, which means that there is a chemical reaction between magnesium metal powder and hydrochloric acid to give hydrogen gas. So I will put a bit of hydrochloric acid here. I'm going to add a little powder of magnesium. Once you notice bubbles, then it means that the chemical reaction is going on. I'm going to see the reaction between zinc and a hydrochloric acid. Here I have a zinc metal powder, and in this test tube I have hydrochloric acid. So we are going to see the chemical reaction that makes us to know that this is a chemical change. Bring out a bit of smoke. So this is my zinc metal powder. I'm adding it. So the bubble shows us that there is a chemical reaction between hydrochloric acid and the zinc metal powder. This shows that there is a chemical reaction going on in these two substances. So a new substance is formed. So we say that the zinc metal powder is reacting with the hydrochloric acid to give us zinc. So as you can see now, there is a bubble going on to show us that there is a chemical reaction. So right now, we will go back to do some equations to see how one element reacts with the other to give us a product. So now we are going to open to our booklet, exercise 9.3, our booklet page 59, and you'll see the exercise there. The first question says, what are the reactants in the first word equation above? This is the first word equation, and from the experiment we did, or we saw, we did put magnesium plus hydrochloric acid. Magnesium and hydrochloric acid are the reactants, and they formed a new product, magnesium chloride plus hydrogen. So our reactant in this equation is magnesium plus hydrochloric acid. Now the second question says, what are the products formed when you react zinc with sulfuric acid? When we react zinc plus sulfuric acid, as we have seen, we did added zinc and added zinc plus hydrochloric acid though. So for this equation, zinc plus sulfuric acid will react to give zinc sulfate plus hydrogen. Now if you are told to write a word equation for the reaction between magnesium carbonate and hydrochloric acid, then we have magnesium carbonate plus hydrochloric acid to give magnesium chloride plus water and carbon dioxide. So our homework will be in our workbook page 76 and 77. I would like you all to go